Today we're going to start with fractions. This is a new chapter. Before we begin, I just want to remind you of last time. So we've covered actually two chapters up till now. So I'm just going to remind you. So we have already covered, and this is so in fact last time हम कर लेते हैं because we actually have been working for a while. So last time we finished off these ideas, and these were big ideas. So we learned something about long multiplication. So we learned two algorithms actually. So let me say we learned the long multiplication algorithm, the long multiplication, and more particularly it was by a two-digit number, right? So as an example, we learned something about maybe 789 multiplied by 43. How do we calculate it? That was something that we learned. Okay, and remember, we were very careful about explaining there were steps to it, right? We actually, so there were two parts to it. We looked at the correctness of the algorithm. So this is an algorithm. We looked at its correctness, and we looked at its speed, and in particular, why do we really need to start, जो हम 789 है, we always start from the right. So we first do 9, then 8, and then 7. And that, I mean, there's a long story to it, but ये हमने दो चीज़ों पे गौर किया था. And for every algorithm, we focus on correctness and speed. और हमने जब ये long multiplication algorithm किया था by in detail two-digit number, तो we proved the correctness, and we showed why is it कि हम right to left जाते हैं, and that really allows us to do it in a very quick way, the calculation. That was one thing. Then we talked about the long division algorithm by, in particular, a single digit number, long division, and I should have said algorithm maybe. That would have been appropriate. And we did the long division algorithm. And what we did was, this was by a single digit number, by one digit numbers. अभी हमने two digit नहीं किया था, by one digit numbers. And as an example, we could take maybe 807 divided by maybe 8. Let's just divide by 8. So we wrote 807 divided by 8, and this is what, and then we worked through that algorithm. But again, uske andar bhi it was the same thing. We looked at two things. We looked at the correctness of the algorithm. Why is it correct? कि हम जो हमारा long division algorithm है, why is it कि when we divide, क्योंकि remember division has a particular meaning. जिस तरह multiplication has a particular meaning, which is repeated addition. Division का meaning ये था कि you want to divide 807 things among 8 people. So why is it that we are doing something which is correct? क्योंकि हमारा algorithm had seemed to have very little to do with the theory behind it. लेकिन then we showed that this is correct. And second thing we talked about again was speed. And the speed really comes from going now, in this case, from left to right. So we were dividing first 8, we using 800s, then 0 tens, and then 7 ones. So this is what we did last time. So ये हमारा sort of the big takeaways were, we learned two very important algorithms, और उसके अंदर हमने उसकी कुछ details हैं, but that's for last time. Any questions about any of this stuff जो हमने last time किया था? Something that may have bugged you? All good? Okay. So now we're going to, you already know something about fractions. So आज का बड़ा topic is going to be fractions. So this is chapter 3. So this is fractions, and this is chapter 3. So let's start out with fractions. Okay. So I want to remind you about a lot of stuff that you may have done in grade 1 or in preschool or somewhere over there, but we'll see how to. So let's think about some fractions that you already know. Maybe a fifth of an apple. Okay, so we'll try to understand it a bit better, or maybe a fifth of a liter of milk. Okay, so now note कि the reason why I'm trying to relate this to something जो आपने शायद preschool या grade 1 में देखा हो कि remember when you started counting a long time back. So this, when you started counting, it was, for example, I'm going to count. Here's counting, right? So 1 chalk, 2 chalks, 3 chalks, 4 chalks. So there was always a denomination. It was always coming with some kind, or we could count pages. So we would have 1 page, 2 pages, then you counted 3 pages, 4 pages, right? So you were counting objects. So यहाँ पे भी I always have an object around me. So this is 1/5 of an apple, 1/5 of a liter of milk, or 1/5 of something, right? I mean, there's always something जिसको हम count कर रहे होते हैं यहाँ पे. So, but then remember that then after a while you realized that there's something common about 2 apples and 2 oranges and 2 bananas and 2 pencils and 2 erasers and 2 chalks and 2 papers. There's something which is a concept of 2, which is common to all of these things, right? That's that abstract thing that we never meet. We never meet Mr. 2 walking around on the street, right? But you can always find 2 chalks in the real world, but you never find the object 2 in the real world, right? That's never found in the real world. So what that means is 2 is an abstract idea that's somewhere in our head, whereas you find 2 chalks and 2 pencils and 2 chairs and 2 people in the real world. Similarly, यहाँ पे what we're going to do is we're going to have a lot of, so I'm just going back to maybe grade 2 or 3 where you learned fractions, that again you can have lots of these 1/5 of a liter of milk, 1/5 of a chalk, 1/5 of a paper, 1/5 of a cake, 1/5 of this, 1/5 of that, and then in all of these there's a common concept which is a fifth, 1/5. And that's what we abstract away, and that's what we are going to be dealing with. Okay, like in something which is very common to what we did from when you went from preschool counting to maybe grade 1 level counting, जहाँ पे you stopped thinking about purely objects, but actually the numbers 2, 3, 4, 5, 6, and 7, यहाँ पे भी हम वही चीज़ करते हैं. Okay, so anyway, just to remind you, it's something very similar. So, what does it really mean? So now we have to think of the abstract, because there's a concept of 2-ness that you got when you started counting, right? So it was the concept of 3-ness that you got when you started counting. That's an abstract concept. Similarly, now I have to explain to you what do I mean by 1/5. What's the concept of 1/5? So now we'll start concrete and then we can do it more abstractly. So whatever the whole is, and I don't know what the whole is. So I'm trying to explain to you the concept of what is a fifth. So there's a whole. In this case, it would be an apple. In this case, it would be a liter of milk. It could be like a bucket of apples. Then this represents the whole, the bucket of apples. And now I'm going to break it up into 5 equal pieces that I will struggle with. 1, 2, 3. So they're equal pieces. So the important thing is I've broken this whole. So this is a whole, whatever the whole is. So that I don't know what it means, but there is something which is a whole. I'm going to break it up into 5 equal pieces. What do I mean by equal?
Equal means that they're equal. They're both the same size.
Okay. Are they, have I broken, so this is the thing, have I broken it up into 2 equal pieces?
Yes.
Do they weigh the same thing? Sorry?
They are equal in size. Equal in size.
So now again, they're equal in size, but it could be, okay, well, I don't have it now. I do have it. Here you go. So but they won't be, this is an A4 paper and this is a letter paper, so I won't have it. Okay, so let's try to find it. Okay, what I'm trying to get across to you is, do I have any object that I might be, but that's going to be, this is going to be roughly the same weight. Imagine there are two papers, here are two papers, they look the same size, but this could be a much heavier paper as compared to this one. So are they equal or are they not, is my question to you. In terms of size, they are. In terms of weight, they are not. So we have to be clear, what are we measuring? Okay? So in general, when we deal with fractions, and it's implicit in what we write, कि हम normally size या area को देख रहे होते हैं. That's what we in general do when we depict this. So this means 5 equal areas or the same sizes. We are measuring the size, the dimensions, and we're saying that this rectangle is the same as this rectangle, which is the same as this rectangle, this rectangle. That's what we mean. But in general, if you have, so whenever you want to deal with equal things, you can have a pizza, and this side of the pizza has more cheese than this side. So I could do an equal share. I could chop the pizza in half and take the side with more cheese, and you would say this is not fair. Right? Do you understand that? So it depends on what we mean by equal. It would have the same area, but it won't have the same amount of cheese. Okay? So it depends. But you need to understand there's a concept of equality here. And then I'm going to take one piece, any piece, I'm just taking the left one. This is what I mean by 1/5. Okay? So if I have 1/5 of a liter, so I'm going to again, remember you have an apple. So if you have an apple and if you have one apple and you get 2 more apples, how many apples do you have? 3 apples, right? That's what we have. So I have 1/5 of a liter. Let's say I have 1/5 of an apple, 1/5 of an apple, and I get 2/5 of an apple. I want to add 2/5 of an apple. Right now I'm again working with denominations. So I have apples here that I am counting. 1/5 of an apple plus 2/5 of an apple. So if I have 1/5 of an apple, I can have, this is going to represent 2/5, right? So it's going to be 1/5 plus 2/5. So this will be equal to, I can count because it's going to be 1/5 plus 1/5 plus 1/5. So I'll have 3 1/5s, which are 3/5. That's how we say it in English. So this will be equal to 3/5 of an apple. Of an apple. Okay? Right? And now you could repeat the same thing because this is a very abstract depiction of a whole. So I could imagine this to be a banana, right? So then I could have 1/5 of a banana plus 2/5 of a banana make 3/5 of a banana. And then I can have 1/5 of a liter of milk and 2/5 of a liter of milk, and I'll get 3/5 of a liter of milk. And then I can continue on till the cows come home, and it will be very boring. And then eventually you say, aha, there's something common here. It is 1/5 plus 2/5 is 3/5. That's that moment when you realize that 1 plus 2 is equal to 3. It's a very similar realization. Is it clear? Yeah? Okay. So we can write it down in general. So this after doing lots of examples. So many examples later. So this is many examples later. You don't immediately get to it. So many examples later, I'm writing it in the wrong place actually. So lots of examples. So यहाँ पे मुझे लिखना चाहिए lots of examples. So you sort of spend your lifetime working with 1/5 of something, with 1/5 of something, 2/5 of something. And then many examples later, eventually you come to the conclusion. So this is what you abstract away from it. Eventually you say, aha, there's something common here. 1/5 plus 2/5 is equal to 3/5. Right? This is that eureka moment that you get. Okay? So now we can add fractions with the same denominator. So this is called, remember, I think you've seen this before, this is called denominator, and we'll see why it's called a denominator, and this is called a numerator. Now remember, denominator is coming from denomination, so we are counting fifths like apples. So this is here, I have 1/5 and I have 2/5. That means I'll have 3/5. Exactly like if I have given apple and 2 apples, I'll have 3 apples, and 1 orange and 2 oranges will make 3 oranges. So fifth is 5 is a denomination. Now the numerator comes from enumeration. We are counting. So this is 1 plus 2, now it happens to be 1/5 and not 1 apple. So we are counting really, this is just enumerating apples. So 1 apple plus 2 apples, we're just enumerating them, are 3 apples. So this is the numerator. Okay? Okay. So now we have some idea that we can add fractions with the same denominator. Right? Okay? So now if I ask you what is maybe 3/7 plus 2/7, hopefully you'll say this is equal to 5/7. So this is what we have learned already. Okay. But before we go on and study fractions on different denominators, and we'll see why we need it, I want to remind you that there's another interpretation of fractions. So let's just get that out of the way. So there's another interpretation of fractions. So let's say I have 2 apples. So this is another interpretation of fractions. Another interpretation of fractions, or what a fraction is of fractions. So here, so what is it? Let's take 2 apples and distribute them, 2 apples distributed equally, whatever it means. It could be by volume or by weight, I don't know what you mean, but some equality sense, distributed equally, and the apples are supposed to be equal to each other also in some abstract way, although you never find 2 apples which are equal to each other, but they're supposed to be equal to each other. Okay, 2 apples distributed equally amongst 5 children. Okay, that's not the same as what we talked about here. Here we had some whole, and we just took 2 pieces, we broke it up into 5 equal pieces, and we took 2 of them. That was 2/5, right? But now we have a different interpretation that I want to talk about, which is here. So now I have 2 apples, and I want to give the 2 apples to 5 children. Now I can't give 1 apple to 5, I can't do it. I mean, that's not possible. I have to chop up the apple into small pieces. So this is what I'm going to do. I have 2 apples. So here are the 2 apples. The apples look very nice and rectangular. So here are 2 apples. And what I'm going to do is I have to give them equally to 5 children. So what I'm going to do is I'm going to break them up into 5 equal pieces. 1, 2, well, okay, the apples, 3, 4. This is going to be a bit longer. So 1, 2, 3, 4, and let's do this. Okay, so now I have supposedly, although they're not quite equal, but whatever, they're supposed to be equal. So I've taken my apple and broken each one of those apples into 5 equal pieces, and now I want to give apples equally to 5 kids. Well, the way I can do it is I can break up my apple into 5 pieces, and then I could give 1 piece from here and 1 piece from here. And I could do the same with the other kid, right? I could give this to this, and everybody would be happy, right, with the so this would be, and this could be just white. Okay, so here right? So do you see कि I have her apple say I broke it up into 5 equal pieces, gave one piece to one child. Then I took the other apple and broke it up into 5 equal pieces and gave one piece to the same child. And then I repeated for each child. Is this clear? That's a very different way of thinking about taking a whole and breaking it up into 5 equal pieces. Now I take each apple and break it up into 5 equal pieces, right? And then from each apple I give one piece to each child. Now note, since the apples were identical, I have actually, so these two yellow pieces are exactly the same as these two pink pieces. Is this clear? Do you agree? I mean, this is much larger, it looks much larger, so it's kind of stupid, but okay, it was supposed to be the same size. Okay, whatever, I don't want to erase it, that's fine. So, but these are, so this means that if you want to distribute 2 apples distributed equally among 5 children, so the abstract question would be 2 divided by 5, and what we have discovered is that this is the same thing as the fraction 2 over 5. Okay? That's the division interpretation of fractions. Okay? So one was a whole, break it up into 5 equal pieces and take the number of pieces which are equal to the numerator. It could be 3, 5, 7, whatever. Yeah, that's one interpretation. The second is you have a bunch of things. Maybe you have, so if I ask you what is 4 divided by 7 equal to, so now we have a question, we have 4 chocolates and we want to distribute them equally among 7 children. What you do is you take a chocolate, break it up into 7 equal pieces, and from each chocolate you would give one piece to each child. Right? And each child would have the same amount as if you took a whole chocolate, broke it up into 7 equal pieces and gave 4 pieces to one child. Do you understand that? There are 2 different interpretations. Is this clear? Yeah? So 4 divided by 7 is actually identically equal to the fraction 4 over 7. So you could go either way. Yeah? Okay, so let me write it out explicitly once. So just so that you remember, both interpretations are useful and we can use both interpretations. So we have 2 interpretations of fractions, 2 interpretations or meanings of fractions, whatever you want to call it, 2 interpretations of a fraction. Maybe I'll just take a concrete example. Let's take 4 over 7. One is, take a whole, break it up into 7 pieces, break it into 7 pieces, 7 equal pieces, sorry, I forgot, and equality ka meaning whatever you wish it to be, 7 equal pieces, take 4 of them. Second interpretation of equality would be, 4 over 7 would be, take 4 things, take 4 holes. So यहाँ पे हमारे पास एक hole था. So now we take 4 holes, distribute them equally among 7 people, distribute the 4 holes amongst 7 people, and each person gets 4 over 7. Take 4 of them, this is equal to 4 over 7, right? So each person gets 4 over 7, right? Okay, is this clear? Both useful, both effective, just you have to be able to comfortably go between the two. Okay. Last thing in this section is, any questions about this? Something which is not clear? All good? Okay. So now we have to talk about, so now the world is not as easy as we would like it to be. Sometimes what happens is that I come along and I give you 1/4 of an apple, and then another teacher comes around and gives you 1/2 of an apple. Now you're kind of stuck, it's not 1/4. Now you have 1/4 of an apple and half an apple, or somebody gives you, and then another friend comes and gives you 2/3 of an apple. Okay, now you have to add up all these apples with various denominators, and you're at a loss because we don't know how to deal with it. So that's what we have to learn. So now remember, when we started out, I had denominations of apples, oranges, liters of milk. I've now given them up and I'm just dealing with abstract fractions. Okay, so let's deal with something simple like a fourth plus a half. Okay, now they're not on the same denominator and we have to worry about how to deal with these problems. So let's just go back to our basic idea, which was a fraction, a part of a whole. So this is called a part of a whole interpretation. This is a part of a whole interpretation. This is the division interpretation. So maybe I should write it down. This is part. So अगर कोई आपसे कह रहा हो, oh, I'm using the part of a whole interpretation. So this is the part of a whole interpretation, and this is the division interpretation. Right? Because यहाँ पे you are dividing things, यहाँ पे you're taking a whole, and so part of a whole interpretation. So यहाँ पे I'm just using a part of a whole interpretation. So I have this. So I break it up into 4 equal pieces. Here I'm going to break it up into 2 equal pieces. So it's the same. The size would be the same. I'm going to break it up into 2 equal pieces, right? Now I have to add these up, and the way we want to add them up is because we only know how to count. We only know how to enumerate. Human beings actually, essentially, I don't know why I don't have a philosophical or deep biological answer, but that's the only we know. We know how to count. So now I'm kind of stuck because I have to worry about a fourth plus a half, and it looks kind of stressful until we realize that I can break this up into 4 equal pieces, right? Once I break it up into 4 equal pieces, now this half is the same as 2 out of 4 pieces, right? So what I can do is a fourth plus a half now becomes equal to a fourth plus 2/4, and that I know how to do. It's just equal to 3/4. Okay. Now, so what we call them are, so 1/4 is equal to is the same. So I'll explain this in a second. What 1/2 is equal to 2/4, and now there was nothing very sacred about breaking it up into 2 equal pieces. We could have broken it up. So remember, this was a half. So remember, this is a half. So I'll draw this here. So this was the idea that you have a half, and this was a half, and you broke it up into 2 equal pieces. So then the half becomes 2/4. But you could take the same half. So now I could take the same rectangle, and this is a half, but I can break it up into each of the halves. I can break it up into 3 equal pieces. There's nothing, so I could break it up into 3 equal pieces. So 1, 2, 3, 4. So now I've taken each half and broken it up into 3 equal pieces. So now this is going to be the same as 3 out of 6, right? And although I can't really continue doing this because my rectangles are too small, but you can imagine taking a half and breaking it up into 4 equal pieces. So this will be the same as 4/8, and I could take the half and break it up into 5 equal pieces, and this would be 5/10 and 6/12 and 7/14, and it goes on, right? Okay, I could do all of these things. Now this equality is kind of not the ideal thing for this. Because equality in mathematics can mean various things. So for example, let's say I can say that, so equality has various meanings, right? So here's a meaning of equality. So there are various meanings of equalities, and sometimes we are sort of a bit sloppy about the meaning of equality. So here 17 plus 14 we know is equal to you get 31. यहाँ पे it's not that meaning of equality. This meaning is not the same as this meaning of equality. So maybe I should call it yellow equality, and this is a white equality. It's a different equality. So this is a yellow equality. This is one meaning of equality, which is do a calculation, and then if you do a calculation, or I could do it even worse, I could say this is equal to 37 minus 6. There you go. Okay. So this is 31, this is 31. You do a calculation on both sides. It turns out magically that both sides are equal. That's one interpretation of equality, because the left side is a mess, the right side is a mess. You work through the mess on the left hand side, you get an answer. You work through the mess on the right hand side, you get an answer. And then it happens magically. You say, wow, you get the same answer. That, okay? It wasn't obvious until you calculated. This meaning of equality is slightly different. These are different names of the same fraction. Okay, so you can have a pet name at home, you can have a formal name, you can have an ID card number or a Form B number or something like that, you can have your passport number. So you can have various identities, but they all refer to the same you, right? You understand that? So if one day somebody calls you a different name, you don't change, you're the same object. Nobody needs to actually do a calculation to figure out, this is the same person. It's the same person. So we have different names for the same fraction. Okay? So this is how you should think about equivalent fractions. They call it equivalent fractions for maybe historical reasons. So equivalent, so these are called, so these are called equivalent fractions. So these are called equivalent fractions, but they are not equivalent in terms of a calculation or something. Equivalent, that's a formal name, equivalent fractions. But they are actually, this is how you should remember them, different names of the same object. So this is how you should remember them, different names of the same object, of the same number. So there's a reality which is a number, and you are just using different names for it. Okay? Is this clear? Okay. So now by using equivalent fractions, we are in a position to add fractions with different denominators. And this is the last thing that we have to do in this section, just one or two examples and then we'll stop. So, for example, let's do question number maybe 6, which is 3 over 8 plus 1 over 4. So this is question 6. So some part 3 over 8 plus 1 over 4. So now you can see I want to put them on the same denominator. So then I can think of this as, because remember I have a fourth. So remember I have a fourth, which means that this is 1, 2, 3. So this is a fourth. But if I take a fourth and divide it into 2 equal pieces, that means how many total pieces will I get? 8 pieces, because 4 2s are 8, right? I have took 4 pieces and broken them up into 2 smaller pieces, so a fourth will get converted. So then the 4 pieces will get converted into 8 smaller pieces, and I am getting 1/4, which means this is equal to 2 over 8 or 2 8s, right? So this will be 2 8s, which will be equal to 5 over 8. And similarly, you could do another question, which may be, you could also add multiple times. So let's do 3 over 7 plus, what do we want? 1 over 14 plus 2 over 14. So now what do? We have a seventh. So what will you do with a seventh? Yeah, we have 7 pieces. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 pieces, 1, 2, 3, 4, 5, 6, 7. So we are going to split them up into each one of them into 2 equal pieces. So 7 2s are 14. So now if you pick 3 of them, that means we're going to pick 6 of them. So this will be equal to 6 over 14 plus 1 over 14. And now we are back to our old friend, which is just counting, enumerating. 6 plus 1 is 7, 7 plus 2 is 9. So we had 9 14ths. And that's where we, this is how we add fractions with different denominators. Okay. So just to, any questions about any of this stuff? कोई चीज़ confuse कर रही हो जो अभी तक हमने cover किया? Okay.
Keep on dividing these sections into infinitely small parts. There comes a point when there is no difference left.
No, so first of all, so you've asked a question. Infinity is not a number.
Yes.
So there is no idea of doing it if, like, much later on, once you go to college or maybe in high school towards the end, you will get the concept of a limit, which is a completely different idea. And it took, if you go back and look at what Newton and Leibniz were doing, it took them, human beings, about 200, maybe 300 years to get comfortable with the idea of how to deal with these infinities. So it's a rather, like for school level problems, we don't deal with, if you continue dividing them forever, that has no meaning for mathematics, because all you can do is you can do 1 plus 2, 3, 4, 5. It's always a finite number that we are dealing with. Okay, so just to remind you, what we have done today is big ideas, just to make sure that we are all on the same page. We learnt about 2 meanings of fractions. That was a big idea. So today we learnt about 2 meanings of fractions. Remember? So that was one idea was part of a whole, or the division interpretation. That was one thing. Then, well, 1 ke baad 2 looks awkward, so maybe I should write 2. The second thing was we learned to add fractions. And we learned about addition of fractions with the same denominator and with different denominators, with same denominators, with same denominator, and with different denominators, with different denominators. And while we were doing this, we learnt about what equivalent fractions were. And remember, equivalent fractions are just names, different names of the same object or the same number. So that's what we did. Any questions? All set? Okay, thanks. We'll continue this next time.